another city, right?
Yes.
Oh, that's so I can understand because I also having same kind of schedule right in front of me. Got no issues. Yeah, I can understand.
Thank you, sir.
Yeah, but try to not to skip the class here, okay? Because
Yes.
we are almost about to done like complete the gravitation chapter, okay? Only the last topic, which is so you can rewatch watch the recordings which is there in your account, okay, dear? So that
Yes,
you
sir.
can revise and so if there is any doubt, so you can discuss it with me. Okay,
Yeah, sure, sir.
okay,
Thank
sure.
you.
Yeah. So some students are still left. Arya left. RS is left. What happened to them? Let me ask. Hello, Arya. How are you?
Good evening, sir. Sorry for coming late. I had some net issues.
No issues. No issues. Good
But thank
evening.
you, sir.
Okay, so let's start the class without any delay. Almost we have waited. Okay, so like almost every student have joined except one or two. So okay, now it's almost complete student, so we can start the class right after that. Okay, so in the last class, dear everybody, what we have done, we have started the thrust and pressure, right?
Yes, sir.
Yeah. So basically, I've told you what is basically pressure. Yes or no? Everybody, am I audible to you?
Yes, sir.
Yes,
Actually,
So
sir.
okay, so can anybody explain me what is basically pressure?
The ratio of force exerted on unit area.
Very good. Who answered this question?
Nabila.
Nabila. Okay, dear. Okay, okay. Okay, so yeah, it's all like it's absolutely correct. Basically, the ratio of the force and the area is called as the pressure. So basically, same kind of you can say. Just let me give you one more thing. So in this, like after this, we'll be starting the thrust because almost we have done the numericals and the conceptual questions based on the pressure, right? You have seen that thing, why we have wider strips of bag and why do a sharp knife is better than a blunt knife. Blunt knife means a knife without sharp edges because sharp knife has a very less area which exerts more pressure than the blunt knife basically, so it exerts more pressure, so it's easier to cut anything with a sharp knife rather than a blunt knife. Clear it?
Yes, sir.
Yeah. And why do we have wider strips? Because basically the pressure, if you have the wider area, so pressure will be less on your shoulders, right?
Yes, sir.
Yeah. Just give me a second. So there is a term which is called thrust. Okay, thrust. Okay, so this is a not a very unique thing. It's not. It's basically the you can say it's nothing but a force. Thrust is nothing but a force. So basically, thrust is what? Thrust is the perpendicular force applied on the unit area. I'm giving you one more. Just give me a second. Let me take some more example if it's there. Why do a tip of needle? Okay. So let me take one more conceptual example based on the pressure because I got I've seen one example which can be there in your real life part. So basically you have seen that basically when we stand on the ground na, so we exert more pressure while we walk? Because like basically when we just a second, let me write this part, which is question. So question is saying that why the pressure on ground, why the pressure on ground is more when a man is walking, than when he is standing. Is my writing readable to all? Please let me know.
Yes, sir.
Yes, sir.
So basically the question is saying that why do we exert more pressure when we walk instead of standing? Is everybody clear? Like how many of you got the question?
Yes, sir. I understood.
Okay. What about rest?
I understood.
Aryan got it. Nabila got it. What about Alvina, Zad, and Reem?
Got it.
Got it? Okay. So basically what happens is that when we walk, we have only, when we walk, what do? We basically put one foot here and basically our left leg, suppose that this is right leg and this is left leg. So basically when we walk, basically our right leg is basically ahead of our left leg. Just assume this
Yes.
thing. Like it can be there, your left leg basically is ahead of right leg, so it basically vice versa. So when you walk, you don't like notice these kinds of things. So I'm just like saying to assume. So basically when you walk, so your whole weight of the body is basically on the right leg while you walk. It means that you have basically a lesser area in comparison to your basically left leg has no basically weight of your body. Only the right leg have the whole body, like your right leg has the whole body weight. Okay, it means that area
Yes.
is less according to pressure force relationship and area relationship. Your area is less, it means that your pressure, the ratio, basically this factor, because this is a force is constant. Yes or no? Force is
Yes,
constant. Now
sir.
your body weight is constant. Does it changing? No,
No.
obviously
Sir.
not. Yeah. So basically, so this area is less, so the pressure will be high. But when you stand, you have your whole body weight is on the right and left leg. So this is a human. So sorry for my bad drawing. Okay, so just saying that thing. Okay, so these are the legs of a human body, and basically you are standing. Okay, it means that you have your body weight is concentrated on your both of your legs. It means that you have greater area than the walking area while you are standing. It means that pressure F by A, it means that area is greater, so it means your pressure will be less on the ground. Clear, everybody?
Yes, sir.
Like my drawing is bad,
Yes,
so
sir.
please try to adjust with this drawing. I hope you got my point, what I'm trying to say with the drawing.
Yes, sir.
Okay, okay. Like I was very bad since I was like my drawing was very good till third or fourth class, but after that my drawing gets deteriorated. When a man, I'm writing the reason here. When a man is walking, so these kind, so in every basically in every situation, same kind of concept will be there. I've shared some book. I've shared the Aschand Lakmir Singh Manjeet Kaur book with all of you. How many of you have that book?
Which book, sir?
Lakmir Singh and Manjeet
What
Kaur soft copy.
book, sir?
I have shared.
Yes.
Oh, so you don't, okay, you don't have the book. Oh, okay, I will share the book again. I think Preshita and like my Salvi, Alvina, I think you have that book, right? Because I've shared that one in the like in the starting of the classes when I was teaching motion.
So you did.
You have that book, right? Yes or no? So, okay, no issues. I will share the book again. So you can go through that check, like basically that book. A variety of conceptual questions are there. So I can take the variety of questions right here, but you can take more examples in the book. Explanation is very good in the books. Very simple language is used. Like NCRT use very concise and very mystery language. But that book is very good because when I was in ninth and 10th, I've also used that book. So that's why I somehow downloaded the soft copy from the internet, and then so that's why I'm basically sharing with all of my students who are with me. Okay, so I will share that book. Don't worry. That's a very good book. Number of numericals are there, MCQs are there. Okay, so it's a very good book. So you
Sir,
can.
what's the book, sir?
The book name is S Chand is the publication name, and the author name is Lakmeer Singh and Manjeet Kaur.
Okay, yeah, I have heard about.
Yeah, yeah. One foot is on the ground. So that book is
And
very good.
what's written after the pressure on the ground is?
Reem, you are saying something, dear?
Yes, I'm saying that what is written after the pressure on the ground is after that.
Pressure on the ground is more when a man is walking than when he is standing.
Okay, so thank you.
Yeah. Due to this, because of this book, I've scored very good marks in nines. Seriously, I'm very honest with this book because this book is very good with respect to ninth and 10th class. For 11th and 12th, I've never used that book because so that's why I cannot say. But for ninth and 10th, I'm damn sure for it. Okay. So you can go with a blind folded mind because that's a very good book. You will understand the book in a very easy manner.
Okay.
Okay, sir.
Yeah. I will be sharing, don't worry, I have a soft copy. So if you want to take printout or you can come comfortable with the soft copy as well, it's up to you. So
Yeah. Yes, I will take the printouts of that copy.
yeah, you can. So like some of the students is comfortable with the soft and some of the student needs hard copy. So it's up to the student by student. Smaller area of the ground. Let me write this first. And produce. More pressure. On the ground. On the other
So,
hand,
what did you write? A smaller area of ground and
and produces.
okay.
Yeah. When Zad, when is your exam, dear? Of science?
Sunday.
You have school on Sunday, dear.
Yes, sir.
Like I think okay. So you are in Saudi, right? So that's why there is no holiday on Sunday, right?
Yes, sir.
Okay, no issues here, no issues. Okay, okay. Monday. Due to this. Course of weight. Larger area. produces. So this is the simplest explanation which can be there in any of the book, and lesser pressure on the ground. I hope it's clear to everybody. Does anybody have any
Yes,
doubt
sir.
in this question? Okay.
No,
No,
sir.
sir.
Yeah. So this is the reason why we exert more pressure when we stand instead of walking, right? Because our whole basically our body weight is distributed over the legs while we stand, but when we walk, our whole body is concentrated on any of the leg. That's why area decreases and more pressure is generated. Clear, everybody? This could
Yes,
be a
sir.
3-marker question in your school. This could be a 3-marker, and it can be a 5-marker. Like how the 3-marker for 3 marks, 2 parts of this question, 5-marker, 3 marks for this explanation, 2 marks. There can be a numerical, like this kind of numerical which we have done in the class. 2-marker numerical. Clear?
Yes, sir.
Yeah. I hope
Sir.
it's clear to everybody. Yes or
Yes,
no,
sir.
everybody? Yeah. Okay. Okay. So basically, so let me tell you what is basically thrust. So we are done with this pressure. Let me tell you what is thrust. So thrust is nothing but when a force, suppose that thing, this is so let me take a surface. So okay, let me take one thing, suppose that thing. So a kind of rocket, suppose that thing. How many of you have seen the rocket in real life, a fighter jet?
I have seen
Very good, very
like
good.
in the
Like,
sky.
right.
Yes, Arya, you are saying something, dear?
What
Urmila,
area have you ever?
I'm saying that how many of you have seen the real fighter jet?
No, sir.
Oh, okay. Basically, in India, on Republic Day, Republic Day and Independence Day, basically this is a kind of show of the Air Force. So that's how I've seen that thing, the real fighter jet in my life. Okay. So suppose that this is a rocket. Sorry for my bad drawing. I have used 3 different shapes to make a rocket. Okay. So you have seen that how many of you have seen like a rocket launch in a movie or in a video?
I have seen.
Movie.
You have seen that thing. So you have
Yes.
seen you have always seen that thing, a kind of basically a kind of support is there, like this
Yes.
thing, and the wires are basically connected with this rocket, and the rocket is basically vertically standing vertically with the basically it's making 90-degree angle with the ground. Suppose that thing, this is the ground, this is ground. Yes or no? This is ground. So 90-degree with the ground is like this and rocket is this. So 90-degree angle is there now.
Yes, sir.
Yes.
Yeah. So, and when the rocket goes upwards, it applies some force in this, basically in the, you have seen like a kind of, this is the fire coming out from the engine of the rocket.
Yes.
So it exerts some force on the ground and rock is yes or no, because if
Yes,
the
sir.
rocket needs to go in the
Yes, sir.
space, it has to exert some pressure on the ground, force on the ground to basically to raise basically to go in the sky.
Yes.
Yes,
So
sir.
basically you have seen this thing, rocket is applying force on the 90-degree of the ground. Basically the specific angle between the ground and the rocket is 90-degree for basically, so the force applied by the rocket is at 90-degree. Yes or no, everybody?
Yes, sir.
Yes, sir.
Yeah. So that force which is applied at an angle of 90-degree is called as thrust. So basically, we in the like rocket science, the word force is not used. Instead of that word thrust word is used. Thrust.
Okay.
Okay. So that's why thrust word is I like it's a very like it's nothing but special, but a normal force. But when the force is applied at 90-degree of the ground, that force becomes thrust. Clear, everybody?
Yes,
Yes, sir.
sir.
Clear.
Yeah. So the force acting on a body perpendicular to its surface is called thrust. 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 Clear?
Yes, sir.
Yes, sir.
And the SI unit of thrust is also Newton because it's a force, nothing but only the direction is used. Because we have specifically said that when a force is applied perpendicular to the surface, that force is called thrust. So SI unit will be Newton. Same as the force. I've used rocket example because because this is the most you can say most relative and most relevant example of this quantity. Okay, so unit of thrust is Newton. Clear, everybody? And pressure, if anybody says that thing, so pressure, same thing. Pressure instead of force, thrust will be used. Because if basically if that rocket is basically applying some thrust on the ground, it will exert some pressure, yes or no? Because you can see this thing, you have seen this thing, the engine, basically the exhaust from where the basically you can say the fire comes out from the rocket. You have seen that thing, that's a very small hole. Why? Can anybody tell me why?
More of the
reason-
area, more the pressure.
The reason is in front of you. Can anybody
Because
tell
of
me?
thrust.
Yes, somebody is saying something.
Because of thrust.
No. No. Okay, let me tell you. The reason behind that is thing, if the area is small, basically that hole is very small. If the area is small, so your overall pressure will be very high. If its overall pressure will be very high, it will help the rocket to go upwards in this direction, in this direction. Because it will exert some force, and if you exert some force, the same force will be applied by the ground, equal and opposite reaction. How many of you remember the third law of Newton?
Yes, sir.
Yes,
If you
sir.
apply,
Yes.
so basically that's why that hole is like designed in such a manner that the maximum pressure is exerted. Like you cannot make a hole you can say with the size of needle, because if you make that kind of hole, the engine will burst in itself, because there will be not enough space to come out basically the gases which is in there in the combustion area. So that's why a specific, by the calculation of the scientist, a specific radius, a specific diameter is used for that hole, and for that to get the maximum pressure. And that's how the rocket goes in the sky. How many of you got this point, thrust?
So that means if area is smaller, the pressure will increase, but with thrust.
Yes, because
If
because your thrust is the perpendicular force. Now you are applying the force on the 90-degree to the surface. It means that that force will be called as thrust. Okay.
yes, sir. Okay.
So how many of you got this rocket example when it goes in the sky?
I got it, sir.
I understood.
Got it?
Yes.
Completely?
Got it, sir.
Yes, sir.
Yes, sir.
Okay. Will you forget in any in any part of your life?
Maybe.
No,
Maybe. Okay.
Probably.
Okay, but okay. So sometimes maybe. So whenever you see a video, just think this concept again. You will never forget this. Okay.
Okay, sir.
Zad, Nabila, Arya, Reem, Alvina. Is this clear to everybody? Please let me know.
Yes, sir.
Sure?
Yes, sir.
yes, sir.
Yeah, very
Yes,
good.
sir.
Okay. So this heel one example which I've taken is an example of thrust. You can see this, like you can say not basically this area, like it's not going in the upward direction, but you can see that the force is perpendicular. Yes or no? Because the heel exerts the force at the perpendicular direction, 90-degree. Yes or no?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Okay, so let's do some more example, the numerical part. Okay. And then we'll be starting the buoyancy and the, you can say, Archimedes principle. Just give me a second. Let me take one more example of the buoyancy. Oh, sorry, thrust and pressure. Uh, Let me take some more question. Just give me a second here. Is there any question? All the questions are there for the. So all the questions are there. Like we have done all the types of question. I don't see any question which is very new, or you can say. Okay, so we have done almost all the types of variety of questions which can be there. Like either it is uh, conceptual or calculative. So we have done this thing. So shall we start the pressure in fluids, buoyancy?
Yes, sir.
Yeah.
Okay, chalo, that's great. That's great. Buoyancy and Archimedes. Do you know that Archimedes was a scientist, but he was assassinated, or you can say executed to death by the, you can say, the king.
So
Because yes, you are saying something.
I said why?
Because of this, because of his principle, Archimedes principle. This principle took his death, like took his life. Sorry, not death. Took his life.
So
Then we
Basically,
sad.
shouldn't learn this.
we should.
We shouldn't learn it because they might
No,
kill
no,
us as well. So
no. Actually, the king was not educated, so like king didn't understand the concept of Archimedes, so that's why he ordered the soldiers to execute him. And basically, first king basically summoned the Archimedes to the courtroom, but he refused basically to, you can say, present there. And then he ordered the soldiers to execute the Archimedes, and that's how the Archimedes lives ended. Okay, so let's understand. So I would just that's a, you can say, fact which have shared with you. Don't take it in another way. Okay. So like when I was I was very amused and shocked when I heard this thing as well. I was like in it around it's when I was in, I think, 10th or 11th class when I heard this thing.
Then why are we learning this in ninth?
Dear, it's a very important example. Why? Because the ships which we see in the sea or in the ocean is based on Archimedes principle. Okay. So that's why it's important. It's a real life practical example of the science. Clear?
Yes.
Yes.
Okay. So basically, now we are going to understand the buoyancy word. Buoyancy first. Buoyancy is nothing but, let me tell you what buoyancy. So how many of you like when I was child, okay, I'm very honest with you. When I was a child, when I take bath or shower, so I used to do what? I have like taking a bucket and filled it with water, and suppose that thing यहाँ तक मैंने उसको fill कर दिया, like suppose, just a second, like I filled the bucket till here. Okay. And what I used to do is that I used to take a mug and try to apply some force on the mug to basically to reach basically to so that the mug reach at the bottom end. How many of you have done that thing?
I have done that.
I
Yes, 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 yes.
Uh,
I know that thing because when we were child, so basically everybody have done this thing. Okay, when I came back to school, and take a shower. I used to do this thing. Seriously. Okay, so basically what happens is that when you apply some force, the mug goes in the you can say in the deep end of the water in the bucket. But when you basically when you remove that, you remove your hand, what happens?
It will come up.
It comes out with a bump suddenly, like just there is a spring right there in the water. Yes or no?
Yes.
Okay,
Yes, sir.
like is this example appropriate for everybody? If anybody is getting offended, please let me know, because I've taken this example as a childhood. Don't take it in another way. Please let me know that. Thank you.
No. No, sir.
Is everybody fine with it? Please let me know.
Yes,
Yes,
sir.
sir.
There are 5 students with me. Only 2 students are saying. So please let me know the remaining one.
It's fine.
Nabila,
It's
Reem,
from you, sir.
Saida.
I understand.
Okay, okay, okay.
Yes,
So
sir.
because this is a simplest example which can be there, so that because my study you can say my teaching method is based on the real life examples. That's how I teach. As you have like everybody is there. You have seen that thing in the previous classes as well. I try to relate the things with the real life, what we have done so far in our life as well,
Yes.
right?
Yes,
And that's how physics becomes very very interesting, because I can use the bookish examples and all, but I used to relate them with your real life, so that you can relate them when you do this thing. You just suddenly strike in your mind that, oh, okay, sir taught us this thing. That's the example of Archimedes principle. That's the example when you wear heels, you will understand. Okay, that's the basically the concept of pressure, thrust. When you see the rocket, okay, sir told us that it's a thrust, basically the thrust concept. So that's why I used to relate the things with the real life examples. Okay, so that's that's my teaching style. Okay, so that force. So you have seen you. So how many of you observed that? What like is there any you can say ghost sitting right there in the deep end of the water, which suddenly pushes out your mug?
Maybe.
Maybe. Okay. Okay, basically there is no ghost right there. Okay. Don't okay.
Yes, yes. Yes.
Yeah. So basically there is a force in the water which is called as buoyant force. Buoyant force.
Okay.
Okay, buoyant force which is there in the water, which basically pushes the mug on the upward direction, in the upward direction. Like buoyant force says that, okay buddy, don't go in the deep end of water, काफी हो गया, अब आप ऊपर जाओ. Go in the upward direction. When you remove your hand, the mug suddenly comes up with a bump. Like it comes up with a like of you have basically like when you basically wear springs and you suddenly jumps up. You have seen this thing. The when you strikes on the ground, you suddenly jumps up with a very high speed. So same things happen.
Yes,
Yeah.
sir.
So that's what the buoyant force does. So buoyant force is the force when it applies on the body in the upward direction by the water. So that force is called buoyant force. Clear, everybody? How many of you got this
Yes,
word?
sir.
Please let me know. Please be clear. Be honest with me. How many of you
Yes,
got this example and buoyant
understood.
force concept?
I
understood,
understood.
sir.
Okay. Nabila said, okay. What about Alvina? What about Reem? What about Arya? What about Zed? Zed, why are you silent, dear?
I told you, sir. I got it.
Okay, okay, Reem.
I
Okay, Reem.
understood, sir.
Very good, very good.
Understood, sir.
Very good, dear. Very. Actually, the all the girls have same voices. So I get confused who said yes, sir. So that's why I said take specifically like like basically call this names of every student so that I can get to know. Okay. So Zad, is this clear to you, dear?
Yes, sir.
Okay. So that's what the buoyant force is. Clear?
Yes, sir.
Any doubt, please?
Yes, sir.
No,
Okay,
sir.
okay.
No,
So
sir.
okay, okay, okay. Very good, very good. So basically, so ha. So you have also seen that thing when you basically so how many of you have done the swimming pool like take a bath in the shower, you can say in the swimming pool.
Not sure. I just have swim in the swimming pool.
Okay, okay. So like I've also not done the same thing because I've never experienced that thing in my life. I want to, but I've never like I've never had the you can say opportunity to swim or take a swimming pool shower. So what happens is that when you basically lie on the water, what happens? You basically feel less
You
weighted.
too.
Yes
Yeah.
or
Yes.
no? You feels that okay, my body becomes very flawless and very feather-like type. Yes or no? Okay, so that is because of the buoyant force. That is because of the buoyant force, because your body is applying for your, basically your weight is applying in the downward direction and buoyant force is the upward direction. So it means that, suppose that thing 90 Newton is your body weight, suppose that thing, and 20 Newton is buoyant force is applied. So what is left? 70 Newton. Obviously, your body will feel, you will feel very less weighted. Yes or
Yeah.
no? How many of you got this
Yes.
point?
I have got it this point.
Okay.
Understood, sir.
So let me write this thing. Okay, sorry. Yeah, this drawing is very good. I will not erase it. Okay. So buoyant force, let me write the words. I will write the definition as well for the buoyant force. Let me write the word first. I'll write the definition after that. When a body is immersed, or body object you can say is immersed. Immersed means, can anybody tell me what is immersed?
Drowned.
Fully immersed.
Yes. Basically, when you put the body into the water, it basically gets immersed. It's somehow some part of the body is in the water and some part of the body is in the out of the water basically. Okay, in water or any liquid. Any liquid, it appears you to lose some weight. And feels lighter. Okay, clear everybody?
Yes, sir.
Yes, sir.
Okay. Okay, so let me write the definition of buoyant force or buoyancy. Okay, so the tendency. So if anybody asks what is buoyancy, the tendency tendency of a liquid exert an upward force on an object placed in it, or liquid basically, is called buoyancy. Basically, the tendency to basically tendency of a liquid to exert an upward force on an object is called buoyancy, and that force is called buoyant force.
Okay, sir.
I hope it's clear to you, everybody. Please let me know buoyancy and buoyant force. What is the difference between them? I hope it's clear to you. The phenomena or the property of a liquid to exert the force on a body is called buoyancy, and that name of that force is called buoyant force. Clear, everybody? That's the difference between them. I hope it's clear to you.
Yes,
Yes,
sir.
sir.
And
Yes,
the
sir.
upward force by the liquid, exerted by the liquid, is called buoyant force. Clear? Hai?
Yes, sir.
Hope it's clear. Please let me know, dear.
Yes,
Yes,
sir.
sir.
Oh no, let me write one more line here because थोड़ा सा मुझे ये it's looking a little bit because एक चीज missing है. By a liquid on a board on an object immersed in it, because if the body is not immersed, how will the buoyant force work? Clear?
Yes, sir.
Immersion should be is mandatory. Immersed in it is called buoyant force. I hope it's clear. Please. Okay. So it is the buoyant force. Let me write this thing. It is the buoyant force. Is the buoyant force which makes the heavy objects lighter. Which makes the heavy object lighter. So basically, it does not basically, it doesn't basically, you can say, it doesn't reduces the weight. It just applies the, it's basically exerts some force in the opposite direction, which basically cancels out some magnitude of the force, and that's how you feel less weighted. Clear? Makes the clear, everybody? Have your
Yes,
checks?
sir.
Seems lighter. Seems lighter in water. Okay, so that's what the okay, so that's what the buoyant force is. Okay, one more thing, everybody, please let me know this thing. One more thing is that when the mug is on the surface of the water, just upper surface of the water, so you can see this thing, a little buoyant force is there. When you push a mug with a little force on this, just on the upper surface of the force, it will not come out with a bump type jump. Yes or no?
Yes.
Yes, sir.
But when you put some basically exert some force on the mug and the mug goes into the water deeper and deeper, and you remove that basically your hand or like stops to exert that force, what happens is that it comes out with a bump if if the mug is at the deep end of the water. Yes or no? It means that when
Yes,
the
sir.
body goes into the water deeper and deeper, the magnitude of the buoyant force increases. Yes or no? Got it or not? How many of you got this word which
Yes,
I'm
sir.
basically telling you?
Nabila understood.
Yes, sir.
Okay.
Yeah.
Aryas understood, Nabil understood. What about Reem, Alvina, and Zaid?
I understood, sir.
Okay, you got it. Okay, what about Zaid and Reem? Oh, sorry, Nabila. Oh, sorry, Alvina.
Yes, sir.
Okay. So one more thing, how many of you like recently you can see let me tell you, recently there's an accident happened in the ocean, in the depth of the ocean, like a kind of a two like a billionaire, 2 or 3 billionaires basically made a submarine and basically goes into the deep water. Have you heard this
Yes, sir.
accident?
Yes, sir.
Yes, sir.
I think that is like oceanic something. I'm just not able to recall that proper name of that submarine. A kind of small submarine to basically expedition to make expedition in the depth of the sea. Basically they want to search and search out and see the you can say the uh, parts of the
Titan.
Titanic. Yeah. So what happened is that their submarine crushed into itself. Like submarine was like this, a kind of like this, circular like this. So what happened is that so two legs were there like this, a kind of bird type shape was that. What happens is that when they go into the deeper and deeper part, the pressure exerted on them becomes very high. So basically, the submarine crushed into itself. Like you have seen that when you crush a paper, what happens is that the size of the paper becomes small.
Yes.
Yes.
So same thing happens with that. So basically, when you go in the depth of the water, like apart from the buoyant force, the pressure also increases in all the direction. Clear?
Yeah.
Is
Yes.
everybody
So,
getting my point? What I'm trying to say right now?
Yeah. Yes, sir.
yes, sir.
Okay, the pressure exerted by a liquid increases. Okay, increases with depth. So if you want to see that thing, if you want to basically, there is a very good video on YouTube. So Dhruv Rathi is a YouTuber. I all basically follow him. So it's a very good, like it explains a very like it has a very good explanation skill. He has a very good explanation skill. So he made a video based on that thing and using the animation. So I'm not basically I'm not promoting something. Just be okay. So if anybody wants to watch that thing with the proper explanations in Hindi or in English, basically mixture of Hindi and English, so you can watch them. Okay, I'm just telling you. Because it's a scientific, you can say it's a you can say related to science and physics, so that's why I'm just suggesting if anybody wants to watch it. With increases with depth, okay, and acts in all direction, in all the direction. Clear everybody? Please let me know.
Yes, sir.
Yes,
Okay,
sir.
next thing is as we lower an object into the liquid into a liquid, the greater basically greater upward force of liquid underneath it neat underneath it to basically provides an upward force. So what is the name of that upward force? Can anybody tell me?
Buoyant force.
Buoyant force. Upward force is called the buoyant force. So okay, or upthrust. That one word also uses upthrust. Up. So because you can see that thing. This is the surface, and the force is on the basically in the upward or downward direction. So 90-degree angle is there. That's why upthrust is used because buoyant force is applying the force in the upward direction. That's why upthrust is used. Clear, everybody? I hope it's clear. Please let me know, everybody. Please let me know.
Yes, sir.
Any
Clear.
doubt? Any doubt?
Yeah.
Sure.
Sure, sir.
Yes, sir.
Okay. So I will. Okay. So there is an activity for you. So before coming to the next class, you can do one thing. Take a poly bag and put. You can say one, like you can take like put a heavy thing. You can say a rock, a small rock or something. Okay.
Okay.
So what you will do is that and tie it with a thread. Like suppose that this is a poly bag. इसमें आपने वो रख दिया, you can say rocks, and put it tie it with a thread. So when you tie it with a thread and try to basically immerse them, you can say immerse them into the water. You can see this thing. a little part will be inside, but and some part will be the, like when you weight in the air,
Yeah,
it will be a little bit heavy, but when you weight in the water, you will feel that thing, the weight has been reduced. Okay,
yeah.
so try to do this activity at your home. Okay, so I'm
Okay.
just suggesting so that you basically understand what I'm trying to say, because right now I cannot see show you the proper experiment right in front of me. But when you try to do this, so a little bit more like you can see that thing, how this thing works. Clear, everybody?
Yes, sir.
Please let me know if any of the thing it's not clear to you, please, dear.
Everything is
Yes,
clear.
sir.
Even the mug and water, that doubt is from childhood. Even that doubt is clear.
Okay, okay, dear. Okay, that's great that the doubt is not there. And like, okay, so that's a very good thing. So, okay, just a second. Just give me a second, dear. Just give me a second. Just give me a second. Actually, you have and you will be having an assessment. Just give me a second. Just give me a second, but yeah. So everybody, thrust and pressure assessment will be there right after this class. Okay. So please try to not try to, please attempt that thing. Okay.
Okay,
So
sir.
almost we are about to end the class. So in the next class, inshallah, this
Yes, sir.
chapter will be done, gravitation, which is okay. Our Archimedes principle, because this buoyancy force is a little bit complex topic to understand, because students like if you don't explain it properly with the proper examples, so it's a little bit complicated topic, so that's why it took a little bit time. So but like it seems that time is worth of it, so that's why, don't worry. So in the next class, inshallah, we'll be doing the Archimedes principle and the, like, because there is no exam like question on the buoyancy force. So Archimedes principle consists of the buoyancy, some numericals, not very good variety of numericals, but simple type of numericals, which is there. Like, okay. And
Okay.
a simple topic is there after the Archimedes principle, which is density. So okay, so density is basically, you can say that thing, density is a sub part of Archimedes principle. So we'll be doing that in the class itself. Okay. So okay, so I hope it's clear to everybody.
And sir, one more thing.
Yes, sir.
That you said you told you will send the like
Yes,
MCQ. Yeah.
I will send the MCU. I didn't get the word here.
No. Yeah. Just at the starting of the class, you told you will send the. What was that?
I was saying that that was book.
Yeah. Yeah. Yeah.
Yeah,
Yeah.
I'm
I'm so
sharing that
sorry.
book with the management. They will share with each of you. Don't worry. I've shared the book.
Okay.
Don't worry, dear. Don't worry. I'm sharing it with everybody, because this book is very good and you can find the conceptual questions and the MCQs. So you already know that thing, we have very limited time, only 1 hour we have to cover the variety of numericals, we have to cover the theory as well. So so that's why I take the variety of questions, but when it comes to the practice, so you have to practice on your own, dear. I can provide this material, but you have to ultimately practice on your own now, because I can take the variety of questions, and if anybody have that doubt, please come take that doubt to the class and we will discuss it. Don't, yes or no? Please let me know if it's clear to you.
Yes, sir. It's clear.
Okay.
Yes, sir.
Yeah.
Yes,
So
sir.
that's all for this class, dear. And thank you so much for giving me your precious time. And one more thing I would like to ask, how many of you find the physics class interesting? Please be honest.
I
Because
love it. I love physics class.
Just yes,
okay.
I find it
Oh,
interesting.
okay. Nabila,
Yes,
you are
sir.
saying something, dear?
Yeah, it's interesting.
Okay. What about Zad and Alvina?
So it's very good.
Okay, dear. What about Zad? Zad, why are you so silent, dear? I like I've also like it's a very common thing in all of my batches.
Why did you take money
Yes, sir.
from the school? It's
Yes,
not
Zad, you are
my
saying.
fault. I told the parents it's not my fault.
Okay, okay, don't worry, Zad. Okay, Zad, one more thing. Okay, Zad, you will basically you have an exam on I think this Sunday, coming Sunday. I will take one class before that, and I will cover your this part. Okay, don't worry. Okay, so I will schedule one class for you. Okay, Zad, are you there, dear? Zad, you can tell me on the chat if you're not comfortable to speak, because I'll understand that thing. Okay, so that's all. So you can go and attempt the assessment, everybody. Okay, thrust and pressure assessment right there in your account, which is active, and you can go and basically go and attempt those questions. Okay.
Okay, sir.
So thank you so much for joining me and
Okay,
giving me
sir.
your